Okay, good morning. In the next 30 minutes or so, I'll talk about building a cost-effective and high-performing public cloud. And I will focus more on the commercial and business aspects than on the technical aspects on that. So the agenda of my talk is, first I start with an introduction of the company of CloudProvider, who we are, who our clients are, how we differentiate, etc. Then secondly, I'll give an overview of our previous cloud architecture that we started to build in 2008. Then, of course, as everybody knows, the cloud computing market is evolving. Clients' needs are higher, and due to that, we had some issues with that old cloud infrastructure. And then, to solve those issues, we redesigned our cloud architecture, and I will show you how we built that. And in the end, I will compare the new and the old setup with each other. So I'll start with the introduction. CloudProvider, we're a cloud hosting and infrastructure as a service provider in the Netherlands. We were founded in 2008. We're a spin-off of a shared web hoster, hosting provider. That shared hosting provider still exists today. That was founded in 2000. And currently manage, I think, more than 30,000 websites in the Netherlands. And of course, they started with virtualization, offering virtual servers, and then they added on-demand creation and resizing of server resources, high availability, and then it evolved into a cloud platform. And when that happened, it was spinned off into a separate company, a sister company called CloudProvider. And today, CloudProvider still gets a lot of clients, a lot of leads from that shared hosting business, clients that need more advanced hosting solutions that outgrow their shared hosting plan, go to CloudProvider for more performance. So basically, we offer two products. Both are offered in a pay-as-you-go model, so you pay by the hour. First of all, cloud servers. Those are virtual machines. So clients logged into our portal, selects the number of CPU cores, memory, disk, etc., and hits the create button, and within 1 minute there's a virtual machine live with Linux or Windows or the operating system the client needs. And of course in the portal you can do a lot more things with this virtual machine, like adding public and private IP addresses, set up a firewall, load balancing, see performance graphs, etc., etc. Then the second product we started to offer 2 months ago is, we call it Cloud Apps. That's basically a library of more than 100 open source applications. And a client can select one of those applications, and then we deploy a server, we do the configuration, the installation of that application, and after that we do the whole application lifecycle management as well. So that means like we update the application if there's a new version available, backup, restore, that's included. Monitoring of the application and automatic recovery. So if the application stops working, a new server will be deployed even in another cloud location. And so the application keeps on running. And that's a very popular product these days. There's more demand for it than cloud servers even. And our cloud platform is built using KVM and Linux. We're open source fans. Then, of course, we are not the only cloud provider out there. There are other competitors like the global players like Amazon, Microsoft, and Google. So how do we differentiate with them? First of all, we have a localized approach. So we offer support in Dutch, and we have a data center in Amsterdam. And currently we're only doing this in the Netherlands, but we're looking to expand to other countries and basically in emerging markets like Southern Europe and South America. Then the second differentiator is our ease of use and simplicity. We built the management portal ourselves in-house, and it's really easy to use, and our clients love that. And we just don't offer the infrastructure as a service, but also all the value-added tools that makes the lives of our clients easier. So they can add things like per application performance monitoring, backup, DNS, all kinds of tools that clients need to manage their service effectively. And the last thing we differentiate in is a good performance cost ratio. We use technologies like SSD caching and Infiniband, and we have a low latency, high quality network, and you can get a server for 13 euros per month, so that's really low cost. The average VM that we sell is around 30 euros per month, and then you get 1 gigabyte of memory, 1 CPU core, and 30 gigabyte of disk. That's basically the average server that clients deploy these days. So who are our clients? We have more than 500 clients and also resellers. We have also the option that our portal can be white labeled, so resellers can offer cloud solutions to their clients as well. That's very popular too. We focus on a few target groups like developers, web hosts and ISPs, e-commerce websites, and high traffic websites. That are basically our main use cases. Then a new thing that we did since a couple of months is that we federated with other cloud providers to buy and sell each other's cloud capacity. Because at this moment we only have a location in Amsterdam, but we do have clients that need cloud capacity in multiple locations. So that's why we partnered with other cloud providers to offer that to our clients. And it's a great way for us and for the other cloud provider to sell capacity that otherwise would not have been sold. A few cases that we have as a client that we are proud of. That's the Telegraaf, that's the largest newspaper in the Netherlands that hosts with us. Vonk, that is it's a large web shop. It's the third largest in the Netherlands. GasUnie, that's the national gas company. They do some projects with us, and also they do a lot of calculations. And there's another big news website as well. So this is our cloud portal. As you can see, it's really, really simple, and simplicity is one of our keys. So this is the screen where clients can create a new cloud server. So they select the CPUs, memory, disk size, and hit create, and then the server is up and running. Okay, I'll set a movie, but I'll skip that. So now we'll talk about our previous cloud architecture that we set up in 2008. That consists of 4 layers basically. There's of course storage that provide the disk space to the cloud servers. There are hypervisors that provide the CPU and memory capacity to the cloud servers. Then of course there's a management layer that orchestrates the whole cloud platform. And the last layer that we have is backup. So the hypervisors were connected with the storage, with the SAN, using iSCSI over gigabit Ethernet. And the storage VLAN, we used bonding to increase the throughput, the bandwidth. So we had 4 network interfaces for the SAN and 2 interfaces for each hypervisor. And then there were 3 additional VLANs for the public network, the internet, internal management network, and the backup network. I made an overview, a diagram of that network. Very simplistic. You can see the 4 networks: public, storage, backup, internal management network. And you can see there are quite a few of lines that connects everything. So this is our old previous cloud architecture that we started in 2008 with. Then the cloud market started to evolve. As everybody knows, we saw an explosion of interest and adoption, especially since 2011. So basically since the last 2-3 years. Not only the number of clients were growing, but also our current clients were deploying more VMs, and the VMs they were deploying were also larger. And I found this number online about the expected cloud market growth from a technology blog, GigaOM, and they expect that the cloud market will continue to grow from $70.1 billion in 2008, so now, to $158.8 billion in 2014. So there's still growth. Another thing that we saw is that the workloads that our clients were deploying in our cloud were also changing, were shifting. So in 2008, 2009, there was a lot of test environments, development environments, and clients were hesitating to put their production loads into our cloud. But that changed since 2011. Now clients apparently start also to put production environments into our cloud. So that's great. Another thing we see is the rise of big data or high transaction volume applications and databases. For example, the web shop I mentioned earlier, they started to not only store all the orders they get, but they also do real-time analysis on all those orders to offer their clients, for example, recommendations of other products they could buy in the web shop. And that's really getting popular, even also with the SME market that we focus on. And because of that shift of different workloads, clients started to have higher demands to cloud providers. So what they wanted is a better reliability and availability, of course, since if we're down, then their business is down too. They also wanted, especially for the big data applications, higher performance and lower latency. And performance, of course, in the cloud, you have outside performance and inside performance. Outside is the internet connectivity between the client and the cloud, and the internal performance is the connection between the hypervisor and the storage. And last but not least, they also wanted competitive pricing. The big example is, of course, Amazon. Amazon lowers prices every quarter these days. Of course, they see that, so yeah, that keeps our pricing. We can't go a lot up with our pricing because of that reason. So, because of that growth of the number of clients, number of VMs, and the different workloads, we had some issues with our old cloud architecture. And the main issue was that the internal storage network became really a performance bottleneck. Clients were experiencing higher latency or I/O weight on their servers. That's not great, of course. The storage performance was not always the same. It was inconsistent. So at busy moments of the day, the storage could react in a different way than other moments, and clients don't want that. They want consistent performance. Also creating backups in snapshots, they took a longer time. And to keep everything under control, we were limited, or we were capping the number of VMs we were deploying on a hypervisor to 30, which is quite low. And that means, of course, a lower return of investment for us. And the second thing that we saw is because we needed more and more servers, more hypervisors, and they were all connected with a lot of cables, with all those VLANs needed to be set up and configured. It was difficult to manage and scale, due to the large amounts of VLANs and also a lot of cables, because our rack looked like this. So that was not great. So then, we wanted to fix those issues. So we looked at alternative interconnects. There were three that we were looking at: fiber channel, 10 gigabit Ethernet iSCSI, and Infiniband. And the selection criteria we were looking at was, of course, the performance of that interconnect. We wanted to control congestion. It should, of course, also have low latency. We wanted that the scalability and the manageability should be easy. And of course, it's great to put more VMs on a hypervisor, so the density should be higher. And of course, the cost should not go up too much, since our cost is, our cost price should stay low. So I compared them with each other at that time, and the 1 gigabit iSCSI Ethernet is what we used in 2008. So that only had a 2 gigabit per second performance. And we needed, per hypervisor, 5 connections, 5 NIC connections. And of course, a switch, they were €2,000 each. So those, it was cheap, but the performance was also very bad. The alternatives, then there's 10 gigabit iSCSI, of course. That's a very logical thing to go from if you are using iSCSI already. That offers a 10 gigabit per second connection, so that's already a lot better. That's of course connected with an HPA and one NIC, but the price as of a switch was relatively high, almost 25,000 euros. Fiber channel, that was still quite a low performance, and Infiniband was very interesting because they offer a 40 gigabit per second performance, and there was only one cable and a hypervisor necessary, so that was also great, and the price was not too high. And of course, all those alternative interconnects, they support the quality of service, which was also a requirement for us to look at. Then, okay, based on that, on the price and the performance, we selected Infiniband for the following reasons: low latency, less than 1 microsecond end-to-end, the high performance of the host connectivity, 40 gigabit per second. We were finally able to do consolidation. Infiniband can do 8 virtual lanes, and there's no interdependency between the different traffic flows. It's highly scalable. We could add tens of nodes if we wanted to, and yeah, it just had the best performance and cost ratio. When we selected that, a lot of advisors, people around us were saying, yeah, but Infiniband is not mature, nobody is using it. So then we looked around and we saw that also other cloud providers are using Infiniband successfully, which is Oracle Cloud, for example. Microsoft uses in its Windows Azure solution for their big compute, big data solution that they offer. And in Germany, there's a cloud provider called ProfitBricks, and they're also successful with their Infiniband-based cloud. We chose these solutions for Mellanox to deploy. The Mellanox Infiniscalio switch, and the HCA adapter card for the hypervisor is the ConnectX-2 card. So that's how our new cloud architecture looked like. Yeah, a lot less cables, a lot better to manage. You can see two Infiniband switches. That's for redundancy. Yeah, this is how it looks like. Then, of course, we wanted to see the results of the new cloud architecture compared to the old one. So we did some benchmarking. So we deployed 2 Linux VMs on the old and the new platform, and we used 2 tools, open source tools, HDParm. That's a tool to read, or to check the timing buffered discretes. On the old setup, it was only almost 17 megabytes per second, and in the new setup, it went up a lot higher to 83 megabytes per second. And we also use Seeker to measure the random access time. And in the old setup, it was more than 60 microseconds. And the new setup, that went down to 4.6 microseconds. And another great thing is that we were finally able to deploy more VMs again per hypervisor. In the old setup, as I said before, there were only 30. And in the new setup, we could go up to 120 VMs at this moment. Maybe even higher, but we haven't tried that yet. Also, the duration of backup creation was largely reduced. Yeah, we could keep up with the daily backup schedule that we offer for our clients again. Provisioning a new VM was also a lot faster. It's now under a minute, and before in the old cloud setup, it took 3 minutes. And of course, it's much easier to manage, and yeah, and finally a smaller amount of cables. And then there's a quote from one of our clients. It's called Daikon. That's developing agency in the Netherlands. They build high traffic business websites with Drupal. That's the CMS. And yeah, he said, like, on the old platform we experienced disk performance issues as Drupal needs fast storage access for a large number of MySQL database queries and for file-based caching. And the new platform based on Infiniband has given great performance boost to our clients' websites, making us and our clients happier. So we got a lot of positive feedback from our clients. And there are also many clients that are migrating from, for example, Amazon to us because of the higher speed as well. So that's great. All right, that's my presentation. Are there any questions?